Hello and welcome to my Pre-Algebra review series. This video covers Chapter 2, Section 2, titled The Distributive Property. By the end of this section, you will have explored the distributive property and its inner workings. You will see several examples where the distributive property is put to work and be given a chance to mentally work through a few in the Checking Your Understanding section of this review. Please leave a like if you find this video to be helpful. Give your classmates a heads up too. It will more than likely help them, as it certainly will help this channel to be seen by more students. If you'd like me to cover any of the topics in greater detail, please leave a comment in the comment section below, and I read them and I do my best to address each as time permits. Please subscribe to my channel and ring the bell icon to be notified every time I review a new video. Thank you. Let's do some distributive property investigation. Okay, Objective 1, Numerical Expressions. You can use the distributive property to multiply mentally. So here are key concepts. Let's see what they're talking about. Distributive property. To multiply a sum or difference, multiply each number within the parentheses by the number outside the parentheses. And they've given us a couple examples. So arithmetically, what are we talking about? We can look at here. We have 3 times the quantity 2 plus 6. Well, what they're showing us here is that you take the 3 times the 2. It says multiply each number within the parentheses, within the parentheses, by the number outside, right? So the number outside, the number's inside. 3 is outside, 2 and 6 are inside. 3 times 2, you see it here, this 3 times 2 here, and 3 times 6. They're plus 3 times 6. If this were negative, if this were not a positive right here, if that were negative, it would be 3 times 2 minus 3 times 6. But when you resolve it, so that's how you break it apart and look at these numbers. And we can switch it around too using the associative property, right? So we can associate the 2 plus the 6 and move it. It doesn't matter how we do it, whatever comes first, right? Or using commutative, we can flip the 2 plus 6 and move it to the front of the times 3. It doesn't really matter, the commutative process. So here again, it's 3 times 2 and 3 times 6. 3 times 2 plus 3 times 6. How about this? 6 times the quantity 7 minus 4. That is equal to 6 times 7 minus 6 times 4. Okay? Or you can put it doesn't matter where the parentheses and that quantity live, whether it's in front of or behind the 6. It doesn't matter because of the associative law, we can do that. And commutative. So we can associate these and commute them. So now we look at this, we say 7 times 6, 7 times 6, 4 minus 4 times 6. You see we got the 4 and the 7 in front of the 6 this time. Doesn't really matter. Algebraically, we can say A times the quantity B plus C is equal to AB plus AC, or A times C. B, the quantity B plus C times A is equal to BA plus CA. Okay? A times the quantity B minus C is AB minus AC. Or we could say BA minus CA is like this. So that's, you can see the ways that we can manipulate these and move them around. Example 1, using the distributive property. 1, this is the first time, they'll show it again, another example. Use the distributive property to find 20 times the quantity 102. And we're going to do this mentally is what they're asking us to do. But when you look at it down here, we have the first writing of it is we have the 20 times 102. And so they're going to break this to use the distributive property. So we're going to say 20 times, 100 plus 2. It's just 102, or we can add the 2 together, the same way as we were doing in the previous example. So we're going to write the 102, we're going to write that as 100 plus 2. Okay, then 20 times 100, right here, 20 times 100 plus 20 times 2, using the distributive property. And then when we do that, we get 20 times 100 is 2,000, and 20 times 2 is 40. 2,000, 40, add them together. We multiplied here, we add them together, and we get 2,040. Okay, example 1. Check your understanding. So right now you should pause the video and take a look at these and see if you can figure them out using mental math and the distributive property as we've been talking about. I'll wait for a second. Okay, now if you've finished with the pausing and worked it out or not, we're going to move forward. So on problem A, we're going to use some distributive property here, and we're going to break this up, and we're going to look at how we can solve this in our head if we were going to do it. So the important thing to recognize here is that we have a 53 times 50. Well, we can take the 53 and we can break that into what? With 50 plus 3. And then multiply that times 50. So here we've taken the 53 and broken it into parts so we can use the distributive property. And now we can multiply 50 times 50, which is, so I can do that, I'll say 50, how's this, times 50, plus 3 times 50. When we do that, this is 2,500, plus 3 times 50 is 150. So the answer must be equal to 25 plus 150, 2650. 2650. How about the next one? 30 times 104. Well, as we did before, I'm going to take the 30, and I'm going to leave it right like this. There's a couple ways this could have been done, but this is the way I'll pick. Times 100 plus 4, using distributive property. So 30 times 100 is what? Everybody got that? 3,000? You could have said 30 times 100, which is 300, times another 100, which is 3,000. But it's 3,000. Okay, plus 30 times 4. 3 times 4 is 12. 12 times 10, with the 0 here, makes it times 10. 12 times 10 is 120. 3,000 plus 120 is equal to what? It's equal to 3120. Okay, there's that answer to that one. Answer to this one over here. Now, C, 9 times 199. Well, this is going to be a little bit different. We're going to play a little different mix-up game on this. I'm going to say we're going to multiply this to 9 times 200, because that's an easy number to multiply 9 times. And we had to subtract 1 to get, or add 1 to get to 200, so we're going to have to subtract 1 to get back to the 199, so minus 1. So now that answer is going to be 9 times 200. 9 times 2 is 18. Times 100 is 1,800. So 1,800 minus 9 times 1 is minus 9 equals 1,790. 1,800 minus 9, 1. Okay, very good. Okay, example 2, real-world problem solving. Excuse me. At a Parent-Teacher Association, PTA, pancake breakfast, the PTA served 397 people 4 pancakes each. How many pancakes did the PTA serve? Well, there's 2 ways of looking at this, and they're both probably the same. So we'll go with the first one here. So what it's showing us is that we're going to take a way of breaking this up. You can break this up into hundreds, tens, and units. This is what they did here. They did 300. There's 300 times the 4. So you can, this bigger number, you can take the 4 times each one of those individually. Okay, so we have 300 times the 4 is going to be 1,200. 300 times 4. Then the 90 times 4 is 36, is 360, We have the 1200, 360, and then 7 times 4, the last one here, 7 times 4 is 28. And then you can add those all up, whether it's easy or not. You're going to have to add them up in your head, but 1200 plus 360 is 1560 plus 28 is 1588. Okay? So that's one way of looking at this. The other way of looking at it is 397 times 4 pancakes each person. We can do 400, which is going to be a little easier, I think, because it's going to be less less addition. So we're going to kick this from 397 up to 400 like we did that last problem. So now it's going to be 400 minus 3, because we have to do minus 3 to get back to the 397. So we have to take away 3 from this 400 times 4. So 400 times 4 and 3 times 4. So it's 1600. That's 400 times 4. And then it's minus, right here, minus 3 times 4, which is 12. And again, if you 1600 minus 12 is 1588. It's the same as the answer up here. I personally like the second method, less mental mathematics and gymnastics, I guess, you have to go through. Okay, example 2, check your understanding. As before, pause the film right now and see if you can do this on your own. It's just like we did the last 3 in the the example we had. So it says your club sold calendars for $7. Club members sold 204 calendars. How much money did they raise? Well, go ahead and pause the video. Okay, hopefully you've gotten through it and you've tried it. So now we're going to do the same thing we did before. We're going to take and break this into the distributive property. The rules for distributive property are going to be 7 times, and we're going to break the 200. I say break it into 200 plus 4. So now when we break this down, we're going to have 7 times 200 plus 7 times 4. 7 times 200 is, 7 times 2 is 1400. 1400. And it's a plus. 7 times 4 is, yep, you got it, 28. So 1428 is the answer. Okay, so in this one, example 3, under using the distributive property, this is the second slide called using the distributive property. It says simplify. And what does it say simplify? It says simplify 8 times 15 minus 8 times 5. Well, right away you see there's the distributive property rules that we can play with here and turn this into the distributive property. Because we're going to go backwards from what we've been doing. So 8 is common to both, so we can take the 8 out. That's what we're going to do, is we're going to pull the 8 out of this group. This association of these two numbers, there's like 8 common. There's also 5's common in here, but we're going to deal with the 8. We're going to pull out the 8. So we're going to say 8 times 15 minus 8 times 5 is 8 times 15 minus 5. Do you see that? So this is a distributed rule going in the other direction from what we've been doing. And now that you've done that, you can say 8 times what? 8 times 15 minus 5 is 10. Made fast work of that. 8 times 10 equals 80. You see that? We pulled the common factor out of these two numbers. Consider this as a number. 8 times 15 is a number. It's written different than what we normally would write it, maybe, but it's like minus 8 times 5. Still a number. The number is 40 in this case. But we can pull the 8 out, and now we can have the 15 minus 5. Kind of convenient. And then we just add these together. 15 plus the additive inverse of 5 is 10. And there we go, 80. Okay, example 3, check your understanding. As before, I'll go ahead and pause the video. I'll give you time to pause and try to work these out on your own, and then come back and we'll do it together. Okay, we've paused the video, we've worked them out, now we're going to do them together. So the first one, it's just what we did in the last example you saw on problem A. We're going to look at this, we're going to say, oh, there's a common 7, a factor of 7 in both of these numbers. Like I said, think of this as a simple number. 7 times 21 and 7 times 9. Just think of them as a number. These are factors of those numbers. 7 and 21 are factors of this number. Okay, so we're going to write 7 because 7 is common to both. So we're pulling, as I like to say, we're pulling the 7 out. And we're going to put parentheses here. We're going to regroup these remaining numbers. So we're going to have 21 plus 9. So that's, we've refactored this. We've pulled the 7 out and we rewrote this. Okay, and now it's in a familiar distributive property form. So now we can say 7 times 21 plus 9 is how much? 21 plus 9 is 30. And what does that equal? What is 7 times 30 equal? Well, 7 times 3 is 21 times 10, right here times 10, is 210. Okay? So now B, same thing. We have a common factor in both of these numbers, and that common factor is 12. So 12 times 52, that's this factor, remaining factor from this number or this combination. Okay, so it's 52, and it's minus 62. We took the 12 out, and we got a 62, minus 62. So 12 times 52 minus 62 is negative 10. Twelve times negative 10. 12 times 10 is 120. And it's negative 120. Okay? Problem C. There's a common factor, and that common factor is a 7 in this one. Here's your 7s. These are common. We can take it out and combine these other two and maybe make it easier to resolve this in mental math. So we're going to take, and this time I'm going to put down the parenthesis first. I'm going to say 16, and it's negative, so minus 11 times 7, the number we're pulling out. So 16 minus 11 is how much? I think it's 5 times 7. 5 times 7 is equal to 35. Hopefully you got that when you stopped the video and tried them yourself. Okay, objective 2, variable expressions. So it says here that you can use algebra tiles to model distributive property with variable expressions. So it says use algebra tiles to multiply 3 times 2x plus 5. So there's a typical distributive property formula look. 3 times the quantity 2x plus 5. And here we have it. Each one of these groups is the larger items of the tiles, the green, are 2x. These are the 2x's. Each one is an x. So there's 2 x's as you see. There's 1x here and 1x here. Maybe I should switch colors. Maybe will red work? Here's an x. Oh, did it come? No, it didn't come. Come on, come on. Oh yeah, there it is. Those each are 1x, so 2 of them together is 2 x's. And then the yellow tiles are 1. They're no x. They're just the unit itself, the constant 1. So there are 5 of them. So there's 2 x's and 5 units. And they want it 3 times. So here it is. Here's the first one. Here's 2 x's and 5 units. Here's 2 x's plus 5. Okay? And they want us to regroup them. Okay? So it says regroup so that 3 times the quantity 2x plus 5 is going to be equal to, and they're showing you, 6x plus 15. And when we do that, we get 1, 2, 3, 4, 5, and 6 x's. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 ones, if you will. Okay? That's looking at the distributive property using these tiles. Okay, example 4a. There's going to be a couple of slides here, apparently. Check your understanding. Using algebra tiles to multiply 4 times the quantity, 2x minus 3. So in this case now the 2x's, the greens here are still the x's. And the minus now, we've got minus 3, so the red tiles are negative. Where the yellow tiles were positive, the red tiles are negative. So now we have 2x's and, let's see if I can switch this to, is green going to work? Plus 3 or minus 3. So here's 2x's minus 3. And we're going to do that 4 times. So we got 1 time here, 1 time here, here. So now we've got 2x minus 3 4 times. That's what this equation right here says, or this expression. Okay, so when we put them together, using our knowledge of the distributive properties, we're going to see right here that it comes back right away as 1, 2, 3, 4, 5, 6, 7, and 8 x's, which it shows down here, 8 x's, and minus 12. These are minuses, so we're going to minus 12. So we got 1, 2, 3, 4. Oh, the color didn't change. Still ain't changing. Why not? I don't know why it won't change. There it goes. So now we got 1, 2, 3, 4 by 3. 4 by 3 is 12, so there's 12 squares there. And here's the not minus. Okay? Okay, example 4b. Check your understanding. The answer's already here because of all these tiles. It wasn't easy for me to break it up and let you take time to do it yourself. I decided to do it all on one tile. We'll just look at it together. Use algebra tiles to multiply 3 times the quantity x plus 4. Well, in this case, we have 3 groups. So that's these. Here's a group, here's a group, and here's a group. So there's our 3. Each one of these green ones is an x, okay? And then the yellow ones, the 4 yellow are adding, it's plus 4, okay? So we got 1x plus 4. That's what this is, 1x plus 4 times 3. And when we do that, you get 3x, so that turns out to be 3x, right, plus 12. Okay, that's what we end up with as our solution here. And when we do that, we'll see we have down here, we have 1, 2, 3 x's, and then there's 1, 2, 3, 4, 5, 6 times 2 is 12. So here's our 3 x's and our 12 units, 12 ones. Showing how the grouping actually does work when you do this. Go to distributive property. Okay, example 4c, check your understanding. I think you're getting the picture now. You understand this. We're going to multiply 3x plus 1, that quantity, by 2. Well, here it is. We have, again, you've seen this a number of times now. Here's 1, 2, 3 x's, and here's our plus 1 right here. Plus 1. 3x plus 1. And we want it 2 times. 1 time, 2 times. And when we put these together into one single unit here, we get 6x plus 2. And here we 1, 2, 3, 4, 5, 6, and plus 2. Okay, example 5, using the distributive property number 3. So here's our third example of this. It says multiply. So let's looking at problem A. We have a little hook going on here. They threw us a -5 here as part of this multiplier. So we're going to rewrite it. We're going to say -5 right here times the quantity 4x, -5 times the quantity 4x minus 3. So now we're going to use the distributive property to spread this out. So what do we get? We get -5 times 4x right here. And then we get minus -5 times 3. So that's this group here. And that's how we broke this apart using the distributive property. So now we're going to multiply them. -5 times 4x is minus 20x. And minus let's put it this way. Minus 5 times 3 is minus 15, but it's going to be negative minus 15. So here we got this one, and it's negative right there. So when we simplify this now, we have these two negatives. We're going to have to get rid of them. Okay? So in essence, what we end up with is negative 20x plus these two negative signs cancel each other out to make a positive, and we get a positive 15. Negative 20x plus 15. Problem B, 2x plus 5 times 7. The quantity, 2x plus 5 times 7. Using the distributive property, we're going to take and break this into pieces. So we have 2x times 7. Here's right here. The first piece, 2x times 7. And then the second piece, 5 times 7. Right here. And it's a plus. There's a plus here. We have the plus here. So when we multiply this out, we get 7 times 2x. We get 14. And we get 7 times 5 is 35. And you can't go any further because you can't add the 35 to the 14x because you can't add x's to non-x's. Or as we like to say, you can't add apples and oranges, so to speak. So that's it. It's the answer to that problem. So, example 5, check your understanding. Multiply. So I'm going to sit here and I'll wait. You stop the video and try these on your own. You should be able to do these hands down. We've done them, a number of them now. So go ahead and give it a try. Multiply these out and see if you come out with the answers. I'll work them out with you when you get back. Okay, now that you've stopped the video and worked them out and returned, let's go on and do it. So the first thing we're going to do is we're going to multiply 2 times the quantity 7 minus 3d. And as we showed before, we do that, we break it into its pieces. So we're going to have 2 times 7 minus 2 times, I got the minus here, so minus 2 times 3d. I don't have to do the minus again because I kept the minus right here at this point. Okay? So now you get 2 times 7 is 14. And you get negative 2 times 3d equals negative 6d. Okay? B, the quantity 6m plus 1 times 3. Take it and break it apart into the distributive properties. We're going to have 3 times the 6m and 3 times 1. So 6m times 3 plus 1 times 3. I'm just going to write 3. So now we're going to 6m times 3 is 18m plus 3. And lastly, we have a couple negative signs to deal with. Shouldn't be too hard though. We're going to break it apart easily. First, we're going to say 3 times what? 5t minus, I should put a parenthesis here, and minus, this is the negative here, here's a negative here, so I'm going to put in parentheses, negative 3 times 2, because I got the negative here for the 2 is already here. I had to carry this extra negative here with this parenthesis, so now I can just write the 2 since there's a negative already on that 2 now. It's a little complicated doing it that way. Think through, when you have multiple negative signs like that, you have to make sure you keep them together and group them properly. And when you do that, then you just have negative 3 times 5t is going to be negative 15. 5 times 3 is 15t. And now we have a minus. I'm going to do it the long way. Minus negative 3 times 2 is quantity, negative 6. I kept these together as a group. Watch, I put a bracket on here. We haven't seen those, huh? Bracket. So those are kept together, and that minus sign we're going to bring in later. Now we bring it in. So now it's minus 15t. Minus times a negative is positive, plus 6. Okay?